G'day guys, in this video we'll be going over how to graph cubic equations. And I want to preface this video by saying that there's probably a lot of ways you can go about this. But today I want to share the method that I used in high school. I think this method is the easiest, it's the most intuitive, it's the easiest to understand. And with a little bit of practice, it doesn't really take longer than 3 minutes at all. And normally in these videos, I like to start off with a little bit of theory, like why we're doing what we're doing. But in this video, I just like to start off with an example and we'll just explain as we go. And I think it'll be really awesome to understand, really easy to understand is the goal. And I want to start by saying that I don't like this type of equation, y equals ax cubed plus bx squared plus cx plus d. I don't like this type of equation because it's difficult to understand what's going on. The form that I like better is something like y equals x plus a multiplied by x plus b multiplied by x plus c. And the reason I like this form better is because it's really easy to find all the intercepts of the graph. And once we find all the intercepts of the graph, we can just connect all the dots. That's why this method is so intuitive. And so naturally the best place to start is how do we get the red equation into the form of the blue equation? That's where I want to start. So I want to introduce this idea called a root. And a root is like an x value that when plugged in will make the y value equal to 0. It's like an x-intercept. And some people also call that a solution. So solution, x-intercept and root, for all intents and purposes, mean the same thing. And it's really easy to solve this cubic equation after we have one root. And the easiest place to start is actually just with a guess and check. So with this green equation, is there an x value that when we plug in will make the y value equal to 0? And normally in the exams, because you don't have a lot of time in exams, it's either anywhere from like -2 to +2, in my experience. And it just so happens that when we substitute x equals 1, y equals 0. So y equals 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. So that equals 1 minus 6 plus 11 minus 6 equals 12 minus 12 equals 0. Okay, so therefore x minus 1 is a factor. Yeah, so maybe the question is, what is a factor, first of all? And I want to remind us that we're trying to get this equation in the form y equals x plus a, x plus b, x plus c. And what we're saying is, when x equals 1, y equals 0. The other way of writing that is y equals x minus 1. Because when x equals 1, 1 minus 1 is 0. And so this whole right-hand side goes to 0, and so y also goes to 0. X plus b, x plus c. There we go. So that's a really good starting point. And just to recap, we get that starting point with guess and check. Okay, so what's the step from here? I want to show you this really cool trick. We already have one known factor, x minus 1. And what we can do is we can multiply this factor by a quadratic expression. So we can multiply it by ax squared plus bx plus c. And maybe you can see where we're going from here. But what we're doing is, if we expand this right-hand side out, we actually get a cubic equation. We get a cubic expression. And so if we just scroll back up to that initial equation, we can just combine like terms. And it's really straightforward. I'll show you. Okay, so we can expand it out. So it's like y equals ax cubed plus bx squared plus cx minus ax squared minus bx minus c. And now we can just polish everything up by combining like terms. Y equals ax cubed plus, we have a bx squared and a minus ax squared, and we have a cx and a minus bx. So we have a b minus a x squared and c minus b x minus c. Awesome. So that's an equation for y. But now we also know that y equals x cubed minus 6x squared plus 11x minus 6. Okay, so this is where everything fits together. Ax squared has to correspond with x squared. So a equals 1. We're equating like terms. B minus a equals negative 6. And the other way we can write that is b minus 1 equals negative 6. B equals negative 5. We have c minus b equals 11. C minus b equals 11. C plus 5, because we're minusing a negative number, equals 11. So C equals 6 equals 11 minus 5. And then we have negative 6 equals negative c. And this is a good way to check, right? Negative 6 equals negative c. We can divide both sides by negative 1. C equals 6. And that's what we got here as well. That's really awesome. So now we got values for a, b, and c. We have y equals x minus 1. A is 1, so it's just x squared. B is negative 5 minus 5x plus 6. Now, we're almost there. We are so close to getting it in that intercept form. All we need to do is factorize that quadratic expression. X minus 1. So we want two numbers that when multiplied together equals 6 and when added together equals negative 5. And I've done a video on this previously, so I'll have a link to that in the description. But those two numbers are negative 2 and negative 3. So x minus 2, x minus 3. Because when we expand this part out, it gives that part there. Awesome. So this is the fun part actually. We have x minus 1, x minus 2, and x minus 3 as all factors. And we can use the non-factor law here. So either x equals 1, or x equals 2, or x equals 3. X equals 1, x equals 2, x equals 3. We've just found our three x-intercepts. Really easy. So now we have two possibilities. The graph can either look something like this, where it comes in from the top, and again, two turning points because it's a cubic, or it could look something like this, where it comes up from the bottom and goes the other way. So how do we know which one it is? And a really easy way is to find a fourth point. Because if we have a fourth point, we know which way the graph goes. So I'm just going to erase this for us. And so it's like, well, what's the easiest fourth point to get? And that turns out to be the y-intercept. And then the y-intercept is when x equals 0. So y equals 0 minus 1 multiplied by 0 minus 2 multiplied by 0 minus 3. Y equals negative 1 times negative 2 times negative 3 equals negative 6. So that is our fourth point. And so it must follow that the graph does something like this. And that is how we graph a cubic. Alright, that's all I got. Cheers, and subscribe if you liked it.